My name is Doug. I'm a OpenStack dev at Rackspace. I spend most of my time working on OpenStack and Barbican project in particular. And there's some contact information there if you guys want to get a hold of me. So the title of the talk's a little bit weird, right? So let me explain it. So first I want to talk about snakes, right? And I'm going to talk about different Pythons that are out in the wild. And so I think most people should be familiar with Python 2 versus Python 3 and how they're different. But I want to make a bigger distinction than that, right? I want to talk about sort of Python the language versus Python the software. And so when I talk about Python the language, I'm talking about the actual specification, the semantics, how the language works, right? This is usually what we think of when we think of Python 2 versus Python 3. There's actually a pretty big specification that goes into the details of all the differences in the language. There's actually more differences than you would at first think about. If we use semantic versioning to talk about these things, right? Python 2.7 is actually a little different than Python 2.6 and Python 2.5 at the language level, right? Usually when there's a new version of 2 dot something, it's because something was added to the language that's not available in the previous version. And sort of the change in the major version between 2 and 3 was a breaking change. You know, it was no longer compatible with the 2 whatever at the time. But then at the same time here, the language 3.4 is a little bit different than 3.3. We just heard about async IO, and that's a new feature of 3.4 that's not available in any other 3 Python. But that's still different than Python, the software, right? Like if you were to write a program for Python 3, you would still need an interpreter to run that program. And interpreter is software, right? So sometimes there's interpreters that come out that have bugs, and that's where sort of this minor version of the interpreter comes from. But not a lot of people know that there's more than one interpreter, right? Sort of the interpreter that we're all familiar with is the one that you can get from python.org, which I think technically is called CPython. And it's actually written in C, and this is what most operating systems ship with, is this C Python interpreter. And there's many versions to that, right? And usually the way that works is the major and minor version will match up with the language specification. And the minors are served for bug fixes and stuff like that. So these are actually the 2 latest versions of Python 3 and Python 2. But there's also other Pythons out there, right? And so for example, CentOS 6 ships with a version of 2.6 out of the box. And so if we actually go to the downloads page for CPython, you'll see that there's actually quite a bit of versions that have been released throughout the years, right? And so we're looking here at I don't know, maybe like 100 different versions, something like that. Whole lot of different Pythons. There's also some other alternative interpreters that you may have not heard about. One of my favorite ones is pypy, and this is a Python interpreter that's written in Python. And so there's a couple of versions to this one available, right? There's a pypy 2.4, which is the latest. And sort of the language compatibility of this is Python 2.7. So if you write a piece of software like a Python script that runs in the CPython 2.7 compiler, in theory you can just take that same program and move it over to pypy. Reasons you'd want to do that, pypy is really fast because it's written in Python. Well, I'm not a compiler guy, so I couldn't give you all the details. But it's got a just-in-time compiler that is able to introspect your code as it's running and optimize it. So if you're doing a lot of CPU-bound kind of stuff, then pypy will be really fast for you. Just recently, they released pypy 3, which has a version that's older than the newest pypy regular, but it works with language 3.2. Gets a little complicated. There's also some other Pythons. There's Jython, which is a project that had been dead, but then it's just recently gotten a lot more work being done to it. I know there's at least one team at Rackspace that is working on some Jython stuff. And so this is an interpreter that takes your Python code and then converts it into .class Java bytecode. And it actually executes your Python program on the JVM. Sort of the caveat of these things, or the different interpreters I'm talking about, they really only work with the standard library, right? Anything that's in the Python specification is going to work across all these versions. And there's been a few releases of this. The old one is 2.5, which was language 2.5 parity. There's the Jython 2.7 beta now, which is bringing the Jython interpreter up to Python, the language 2.7. A couple of other ones that I'm just going to talk about briefly is Stackless Python, which is a multi-threaded version of the interpreter. And if you use greenlets and stuff like that and CPython, this is where it comes from. It comes from this Stackless Python. There's also a project called IronPython, which is Python for the .NET language, and it's very similar to Jython in that it compiles to Microsoft MSIL, and then you can run it either on Windows or on Mono. I think it's compatible with that. And so the problem for us then is, like, if you're writing a library, you want to be able to test it against all these different versions of Python. And if you're developing, maybe you want to develop in the same exact version that matches your CentOS server that you're going to deploy it to. And because there's those little bugs in the minor releases, you maybe want to test against a bunch of different minor releases and see, sort of make sure that your code runs in those things. And so that's where pyenv comes in. So pyenv is this, it's written entirely in Bash, is this command line tool that helps you manage different versions of Python. It was written by this guy, I don't know, is his name Yu Yamashita? I don't know. But he seems like a cool guy. I've never met him. I don't know who he is, but I just think he wrote a neat tool. And the way pyenv works is it uses these things called shims to sort of hack into your path and then allow you to do different things, like change your Python version on a per user basis. It provides, you could change your Python version per project if you're developing against different versions. You could also change your version of Python on the fly just based on an environment variable. And so the way this works is by using your path variable in your operating system. Unfortunately, this does not work on Windows. This is Unix or Mac OS only. And so that we're all on the same page, I can talk about the path a little bit. And this is just a list of colon-separated directories in your system. And when you punch in a command into your interpreter or to your shell, if you don't give it a full path to that executable, what the shell is going to do is, in order, is going to look into all these directories that are listed in your path to try to find an executable file that matches the command that you typed in. And then as soon as it finds one, that's the thing it's going to execute. So the way that pyenv shims work is that you prepend this to your path, this shims folder. And the shim is just a very thin sort of a script that at runtime is going to decide what version of Python is the correct one or the active one. And then once it decides, once it figures out which is the version of Python that you want, it's just going to forward that command to that correct version. And sort of the way that it decides which one it's going to pick is by looking at these things in this order. First thing it's going to look for is an environment variable called pyenv_version. And if that's set, then it's going to assume that's the version of Python you're going to use. If it's not there, it's going to look in the local directory for a .python-version file. And if it's there, it's going to use it. And if not, it's going to keep going to the parent directory and its parent directory all the way up to the root, looking for that Python version file. If it gets all the way to the root and never finds this Python version file, it's going to look in one last spot, and that's the version file inside pyenv, which is the installation directory for pyenv. If it doesn't find any of those, it's just going to default to the Python that came with your system. One sort of caveat to this is that sometimes when you install libraries, they give you executables, they add executables to your path. And sort of one of the only downsides about pyenv is that it doesn't automatically find those for you. So every time you install a new library that gives you an executable, you're going to have to run this pyenv rehash command. And what that does is it looks through all your different versions of Python that may be installed, And for any executable in those that doesn't already have a shim, it'll create one for you. And so from that point on, you'll be able to run that command. It's also extensible. It's got a plugin system. One of the plugins that I always install right away is pyenv virtualenv. And this will allow you to then create virtual environments with pyenv. And the cool thing about it is it treats these virtual environments like just another version of Python. So once you create the virtual environment, you can activate it and deactivate it and all that stuff like if it was any other version of Python, right? It'll go through the same steps to decide which virtual environment it is that you should have currently. And so let's see how it works. Nope, that's not the one. Okay, so font's a little small. Can everybody see that? Thumbs up in the back. Somebody, keep going. Bigger, bigger. Is that good? Bigger? Okay, let's see that. Okay, so this is just a virtual machine I just spun up last night. And I installed pyenv already, just so that I don't waste your guys' time on it. But it's pretty simple. Basically, just did a git clone of pyenv, which I didn't show you guys, but it's in GitHub under this GitHub. And I just git cloned it into .pyenv. And then inside there, inside the plugins, I did the same thing with this Python virtualenv. I just git cloned it. Finished the installation. Bash RC. I just added a couple of things to my bash RC. I'm going to export the root of pyenv, which is that .pyenv directory where we cloned it. Then I'm going to pin that bin to the path so that before anything else in your path for Python. And then this eval pyenv init, this is just adding autocompletion to bash. Sort of a similar kind of autocompletion thing that's supposed to like auto-activate virtual envs for you, but I haven't gotten that to work very well for me, so I skipped that part. And so what we can do now is say pyenv install, and then I can just hit tab to autocomplete. And these are all, oh wow, that's not gonna fit. We're scrolling. These are all the different versions that pyenv currently can install. Now when you install this, it's actually going to compile that interpreter on your system, so you got to make sure that you've got all the dependencies there. There's a little wiki article on which dependencies you need in case you don't have them already. And as you can see, it's got a lot of versions from 2.1 all the way up to 3.4 development, which I think just pulls whatever latest snapshot is from the repo. Anaconda, Miniconda, these are scientific Python distributions that you can install. It's got that stack list I mentioned earlier, a whole bunch of different pypys, some of these Jython builds and stuff like that. And some more stuff. And IronPython too, if you're into mono and things like that. So once you install something, you can say pyenv versions, plural. That'll show you everything that is currently installed. I pre-installed some of these because it's compiled at installation time. I wanted to save some time. I pre-installed some of these ahead of time. As you can see here, I've got my system version. The little star means is the current active version. And I've got these other 4 that are available to me. Now, one thing I don't like about pyenv that was really cool about like virtual env and virtual env wrapper is that it shows you on your prompt like what the current version is. But there's a way to sort of get around that. Make this big. There's a prompt command option in bash that'll actually run a command right before it shows you the prompt. And so what I did here is, we'll take the fancy version here. Just paste that in. And so what I'm doing here is I'm running this pyenv version singular command, or actually version name. Version singular shows you what the current active Python is, in this case system, and then I've got this command that'll show me like in a blue right above my prompt what the current one is. So to set the current one, I could say pyenv global, and this is going to set that sort of last result one. gonna say that's gonna be 341. You can see now that my active version is 3.1. I could also say pyenv local. Let's go with 2.7. Now it changed the current one to 2.7, but also it added this .python version to the current folder, and that's how it's figuring out. If I actually ask it what the current version is, it's going to show me is 2.78 because it found this version here. If I remove that file, you see that it goes back to 3.4 and it's there. Another cool thing you could do is just temporarily set your shell to some other version. So maybe real quick, I want to jump into 2.6 and do something. Not shell. And now if I ask it what the current version is, it's going to tell me it's 2.6.9 because it found that environment variable. I can unset that, and it goes back to, pyenv shell unset. And it'll go back to whatever my global one was. So that's pretty cool. Another cool thing that I could do is actually, where's my local? pyenv local. So when I activate 3.4, 2, let's see, 3, and 3.2, no, 2.7 and 2.6 all at once. What that's going to do is, in my path, it's going to add not only Python, but Python dot 2 dot something, 2.6 to that. And all those are going to be available to me. And one of the cool things that you can do with this is run tox. Now, if you're not familiar with tox, it's this thing that lets you run tests in parallel against multiple different versions. So let me first make a pyenv. Virtual env with 3.4 and call this tox. Let's make that one first. Okay. Hit install tox. This should work. So what I'm doing now is I'm installing tox on my local directory. I've got this pretty easy project out here. So set up a real simple project. It's just 2 files. One of them just prints hello PyTexas. Then I've got a test for it. That'll test that the message is what I expect it to be. And I don't have a tox in my file, that's not good. I thought I had set up this tox file, but man, let's just copy this thing real quick. Notice. And the way tox works is you give it an environment list. These are some predefined environments. And what this is telling tox is I want to run my test suite against Python 2.6, Python 2.7, 3.3, and 3.4. And the command I'm going to use that is nose tests. And what I could then do is just run tox. It tells me there's no such file or directory. That's because I did not pyenv rehash. And so what it's doing now is actually creating a virtual environment in each one of those different versions of Python to run my test suite against. So you can see here Python 2.6 passed, Python 2.7 passed. Python 3.3 is currently being tested. Oh, there's an invocation error there. And I'm expecting Python 3.4 to do the same thing. That's because if we look at my little sample program here, my print statement doesn't have any parentheses, right? So it works in 2, but it does not work in 3. And so to fix this, what I can do is from future import print statement. And if I run my talks environment again, I should see a fail on everything now. And if I just add parentheses to my talks file, I should be able to now, oh no, what happened? What's the print function? That's what it is. Okay. What am I going to do? Function. Let's try that. And now we're happy. So that's pyenv in a nutshell. Does anybody have any questions? Yes?
What happened with your virtual env instead of with your bash RC that you said?
So what that adds is, like, you know how you can bin activate your virtual env and it'll add it? So like it'll do it the first time, but then when you go back in, it won't reactivate it again the second time. So it'll activate it when you cd into a directory, and then it'll deactivate it when you cd out, but then the second time it just wouldn't work. Another cool thing, I can actually show you my actual box. So the way I have mine set up is I've got sort of these two little playground virtual environments, but then as I change into my different projects that I'm working on, for example, here I've got 3 different virtual environments set up. If I go into maybe a different project, I've got another one set up. And so that's one of the cool things that I like that's better than virtual environment, is I don't have to be juggling like what environment is active. As soon as I cd into that directory, because of the way I've set up like those files in all my projects, it just knows which one I want to use. Yeah. Any other questions? No? I think I blew through this pretty quickly. Yeah, we actually did pretty good on time. Alrighty, guys. Well, yes.
So, I'm only been in Python for a year now, so I'm kind of confused because everyone talks about virtual env all the time, and so now we have something that looks like it runs beneath virtual environment. Is that what's actually going on here?
So. Okay, so you're confused about virtual environment and how this plays along with virtual environment, or whether it's a...
This is happening at the bash level. It does many of the similar things in virtual environment. Python 3.4, which is what I use as virtual environment, did. So I'm trying to understand.
Okay, so let me, I guess the question was, how is this different than virtual environment, or how is it better? So virtual environment, the problem it's trying to solve is being able to install more than one version of a library into your Python, right? And so that's one of the limitations of Python, is that if you upgrade the library you're using, it'll override the old version. And so virtual environment lets you create a little silo where those third-party libraries can live without overriding each other, right? But that's still limited only to a single version of Python. This augments that in that it'll allow you to then also have different versions of Python at the same time. Now, you could probably get away with Python 2 and a bunch of virtual environments, and Python 3 and a bunch of virtual environments with just that. But if you wanted to test against like 2.6 and 2.7 at the same time, then that's when you would need a tool like this. Does that help answer your question? Awesome. Cool. Alrighty. Well, thank you guys. I'll be around.